Okay, this is 8th grade lesson 3.4. Our objective today, students will solve real life problems using equations, graphs, and intercepts. The standard covered in this lesson is 8F4 and AE6. The page numbers are 126 through 131 out of the hardcover book and pages 67 through 70 out of the practice journal. Yesterday, we started working with some real world scenarios and graphing those out, but yesterday we were given the X and Y intercepts. Today, we're going to have to work off of an equation to be able to do that, and then we'll answer some questions from that. So here's our first situation. It says the percent Y in decimal form of battery power remaining X hours after you turn on a laptop computer is Y equals negative 0.2X plus 1. Graph the equation, interpret the X and Y intercepts, and then after how many hours is the battery power at 75%? Okay, so to graph our equation, remember we always start in the back end. So our plus 1 is the same as 1.0. And then it was down 0.2 over 1. Now I know you guys haven't worked with decimals, but because of the way I have the graph set up here, we can go ahead and graph that out as down 0.2. So down 2 boxes, each box is worth 0.1 over 1. And we'll just continue down 2 boxes over 1. And if you would like to draw your straight edge using your straight edge, that's okay. Okay, so it looks like we ended at 5. Now it says interpret the X and Y intercepts. So I need to go back to my story problem to understand what my X's and Y's were representing. So it told us that the Y is the percent remaining. So percent of battery remaining. And then our X's were the number of hours. Okay, so if we're going to interpret that, well, our Y-intercept is 100%. And our X-intercept is 5 hours. Okay, and I'm just pulling that data off of just where they are on the X and Y line. So it means that originally at hour 0, it had 100%, and within 5 hours, it'll be down to 0%. Okay, so that's graphing our equation. We've written out our X and Y intercepts. Now it says after how many hours is the battery power at 75%, which is the same as 0.75. So our original equation, scroll up, is right here. And the percentage, remember, was our Y. So if we put our 0.75 where Y is, it would look like this. Equals negative 0.2 X plus 1. So now we'll solve for X, so minus 1, which would give us 0.25 negative equals negative 0.2X. Divide by 0.2, divide by 0.2. So we're going to go ahead and figure out what 0.25 divided by 0.2 is. And when I do that, I get 1.75. So I just found out that X equals, 1.25 hours. So 1.25 hours or 1 1/4 hours, 1 hour, 15 minutes, however you would like to go ahead and write that out. Okay, so sometimes they're going to have a substitute in and solve. And had I tried to do it off of my graph, since I did my graph, well, 0.75 would be somewhere in here. And it doesn't land exactly on a line, but I could see that if I were to draw this line through it, it's going to fall somewhere in here. And that is a little over an hour, but I couldn't tell from the graph exactly how much it is. Here I can, when I substitute in for Y and solve for X. Okay, so let's go ahead and try another one here. Now on this next one, you can use your graph, so you should be doing what I'm doing on your graph. Oops, forgot to put my marker down. Oh, there's more space here. Okay. So now we've got the amount Y in gasoline. So you guys on your whiteboard should be doing the same thing that I'm doing. Okay, so the amount Y in gasoline, in gallons of gasoline. So our Y's are gallons. remaining in a gas tank after X hours. So our X's are our number of hours, which I already have labeled there, is Y equals negative 2X plus 5. I'm going to bring that down here. Negative 2X plus 12. Graph the equation. So if we graph the equation, remember we always start at our back end. So we'll start with this part of it right here. Plus 12, so positive 12 is there. And then we're going to go down 2 over 1. So down 2 over 1, down 2 over 1. And if you want to use your straight edge, you can. Okay, so it looks like we end up at 7 hours. So now it says interpret the X and Y intercepts. Well, our Y-intercept is 12 gallons. So that's how much we start out with. And our X-intercept is 5, sorry, not 5, it'd be 7 hours. That's how long our gas will last us. It says after how many hours are there 5 gallons left? So once again, our gallons, if I were to check 5 gallons, it's falling in between 6 and 4 hours. Somewhere in there. So I would guess it to be 5, but we'll go ahead and solve as well. We know that it's 5. It's going to be, between 3 and 4 hours. So if I go ahead and we know that it's got to fall in there somewhere, we're going to plug in 5 where Y is in this equation. So I get 5 equals negative 2X plus 12. So minus 12, minus 12. I now have let's see, 7, which is negative, equals negative 2X, so divide by negative 2. Divide by negative 2, I just found out that X, which is our number of hours, equals 7 divided by 2 is 3.5. So for letter C, it would be 3.5 hours. Which, yeah, that falls in between. If we were to follow this down, okay, going down there would be about 3.5 hours. But there I'm just trying to guesstimate. Here I'm giving and showing proof that it is the 3.5 hours by substituting into my equation. All right, let's try one more. It says you are downloading a song. The percent Y in decimal form of megabytes remaining to download after X seconds is Y equals negative 0.1X plus 1. So this is similar to what we did in the first one. So let's go ahead and graph or label our axes. So Y is our percent of megabytes remaining, percent megabytes. Remaining. And then our X's would be seconds. Okay, so now we're going to go ahead and graph our equation. So we always start here. So our plus 1 is our 1.0. And we're going to go down 0.1 over 1. So down 0.1 over 1. Down 0.1 over 1. So we'll just continue in that pattern. And it looks like we end at 10. Okay, so we've graphed the equation. Interpret the X and Y intercepts. Well, our Y-intercept is, 100%. And our X-intercept is 10, and that would be seconds. So it's going to take us 10 seconds to download those megabytes. Letter C says, after how many seconds is the download 50% complete? So if I were to check 50%, now here I can go off of my graph. So if I find 50%, here's my line. Really bad line. Okay, 50% is here, 0.5. And it looks like it crosses right here, which would be 5 seconds. Okay, if you're not able to read the graph, or you're using, maybe you're using your graph and you don't have it set up as 1/10, then you could substitute in 5 seconds where y is. So if I were to take this equation here, and put 5 where y is, 5 equals negative 0.1 x plus 1. So then we would say minus 1, minus 1. So then, and that's 5, right? 0.5. So then I would get 0.5 equals negative 0.1 x divided by negative 0.1 divided by, and that's a negative 0.1. It would give us x equals 0.5 divided by 0.1 would give us 5. And that's the same thing as what I had here, but I was able to pull that off of the graph. Okay, sometimes you'll be able to pull it off of the graph and other times you won't. You'll have to use that equation to solve for that. Okay, as long as they give you either the x or the y, you can always solve for the other. Okay, so let's go ahead and try working another one. So here it says this, the graph relates temperatures y in degrees Fahrenheit to temperatures x in degrees Celsius. So our y's are Fahrenheit, degrees Fahrenheit, and these would be our degrees Celsius. Okay, find the slope and y-intercept. So our y-intercept is where it crosses the y line. Okay, and that would be at 32. Okay, and our slope, well, to do our slope, we need our rise and our run. And that's kind of hard to do off of this graph because it's falling, this dot right here is falling between two boxes. So we're going to go ahead and do our change in y. So here's our y's over our change in x. So if I originally start with 86 minus 32, these are our y's. Remember, this is going back to, I don't know, chapter 1 or 2, working with slope. And then since I did the 86 first, I have to do the 30 first in my second one, minus 0. So now if I go ahead and do 86 minus 32, it's going to give us 54 over 30. Okay, so that's our slope, which that can reduce down because 2 could go into both of those, or yeah, 2. So this would give us 15. And then 54 divided by 2 would be 27. Oh, I can still use another 3 could go into those also. So 3 could go into 27 9 times over 5. So we've got 9/5 is going to be our slope. And that's a positive slope because it's going up from left to right. Okay, so we've written our equation. No, we haven't. We found our slope. So now it says write the equation of the line. So for letter B, so this was our A. For letter B, well, our equation is y equals our slope was 9/5 x, and our y-intercept was positive 32. Okay, so there's our equation for B. Letter C, what is the mean temperature of Earth in degrees Fahrenheit if the mean temperature in degrees Celsius is 15 degrees? Okay, so now they're not giving us the letters X's and Y's. They're talking about Fahrenheit and Celsius. So let's go ahead and identify. Okay, the Fahrenheit was our Y's and our Celsius was our X's, right? So if we go through and we substitute in, so they're asking what the average temperature in Fahrenheit would be if the mean temperature in degrees Celsius is 15. So if I put a 15 where X is, so 15 here, and we solve for our degrees Fahrenheit, which is Y. Okay, so 9/5 times 15. So 9/5 as a decimal would be 1 4/5. So 9/5 times 15. And then we're going to add 32 to that. Whoops. Let me redo that. 1.8 times 15. And then add 32. Gives us 59 degrees. So for letter C, it would be 59 degrees. Okay, so that's once again working another one where they're asking us to go through and substitute in. And this one was kind of tricky because they didn't give us those C's and F's and X's and Y's, although on the graph they are identified that way. I'm noticing here on the graphs they are identified C and F, but we're used to working X's and Y's in our equation, so understanding how to pull that information. Okay, so let's go ahead and try one more. Okay, so it says the graph relates temperature Y in degrees Fahrenheit to altitude X in thousands of feet. So our X's and Y's, they were working with feet for our X and temperature in Fahrenheit for our Y. Find the slope and the Y-intercept. So our slope, once again, we can't use the boxes. So we're gonna have to do change in Y. So that's subtracting. So I'm just gonna go ahead and start with, it doesn't matter which one, I'll go ahead and use that. So our Y there was 59 minus, then I have to write the Y of this one, 33.8 over, since I started with the 59, I have to start with the 0, minus 7. Okay, so now if you want to, you can pull your calculator out to get those differences. So 59 minus 33.8 is going to give me 25.2 over 0 minus 7 is a negative 7. Okay, so when we go through and we reduce this down, 7 will go into that 25.2, 3.6 times. So our slope, and I know that you guys aren't used to working with decimals for slope, but we can write them out that way. Our slope is going to be 25.2 divided by 7 is 3.6, and that's a negative 3.6 because we have one negative there. And then our Y-intercept is where it crosses the Y line, which here they've already identified for us. I know it looks like it's at 60, but it's really right here, the 59. Okay, write in the equation of the line. So we're just going to use our information that we just had up above and fill it into our equation. So Y equals, our slope was negative 3.6x, and then where it crossed the Y-intercept was 59, so plus 59. And letter C, what is the temperature at sea level? So sea level is this, is our 0, sorry. So temperature at 0, which is our sea level. Well, it looks like it's a little bit above or between 14 and 16. So if we plug in for X 0, not for X, sorry, for Y 0 equals negative 3.6x plus 59. So then we would say minus 59, minus 59. So now we have negative 59 equals negative 3.6x. And I can see that it's falling between, it looks like it's really close to 16. And maybe it is exactly 16, but we'll double check that, because these are so, there's such a big change in the boxes. So now we'll divide by negative 3.6. Divide by negative 3.6. So 59 divided by 3.6. So I've got two negatives, makes it a positive. It's 16.38. So it's actually a little bit past the 16 now that I really look at it. So 16.38 repeating, or 16.4. And that's our temperature. So that would be degrees Fahrenheit. Either of these would work. So once again, looking at that graph, I thought it was a little before, and now that I look at it closer, it did fall after the 16. So we had to use the equation here to find the exact answer. Okay? All right, so that's it for real world problems, working and solving and substituting in. So good luck with this, and just remember that when you're solving for either X or Y, make sure that you're isolating those.